Hi, my name is Damon Rocha. I'm a student at the University of Advancing Technology, studying computer science, robotics, and embedded systems. Today I'm going to cover my student innovation project, AstroSwarm, a secure distributed drone network used for mapping hazardous environments. Natural disasters are a major problem in our world today, cause a lot of destruction, and in the wake of that, many individuals get stranded or trapped, injured. There are various companies and individuals who come to the aid of these people, and they can use more information before going into these hazardous environments. Using drones and blockchain, they'd be able to securely map these environments, get some more information on what they're about to get into, and give the people who are about to go into these hazardous environments more of an idea of what they're getting themselves into, thus saving more lives. The technical fields this project will encompass are computer science, autonomous systems, blockchain, and robotics. The components of this project will consist of 2 autonomous mapping drones, a private blockchain, and a human-run control node. The control node will add waypoints to the blockchain, whereas the drones will then pull these waypoints and add the data of their surrounding area. This will allow all the data to exist on the blockchain, which will be shared across the 2 drones and the control node. So if any one node is lost, not all the data is lost, and even some of the data collected by that node will still be a part of the overall blockchain. The vision of this project is to combine 3 technologies that current state don't have many production use cases of blockchain, swarm robotics, and autonomous systems. Save as many lives as possible and aid those saving lives in the disaster relief industry. Current state, there are no products on the market that use these 3 technologies together. There are various educative articles and journals that are being researched currently that use similar use cases for drone mapping of cities and just various drone mapping using cloud-based technology, but none for drone mapping in hazardous environments or the disaster relief industry. For early stage prototyping, I made these 2 diagrams that shows the blockchain logic and the project end state. Starting with the project's end state, we'll have these 2 drones in my backyard and a command center which I will be running. That will work as the command node. I will give drone 1 mapping area 1, drone 2 mapping area 2, and they will go through and map those 2 areas. I also have a few testing scenarios where one drone goes offline and see if the data still comes back. They both go offline, check the data, and then a hostile device that tries to hack in and take the data. As for the blockchain, the logic of this is the command node will create the blocks. The blocks will consist of a location name, if there is any drones using it currently, any data on it currently, whether it's been visited, and whether it's in progress or not. And each location will point to the next location that needs to be mapped, and all these will exist in a task queue. The drones will pull waypoints from the task queue. One thing I missed adding to this is an in-progress queue, and then going a little further into the drones' systems. But I figure since this project's mainly the blockchain and mapping, I'd cover the blockchain a little more for the control side of things. Lastly, I guess not lastly, but the target market of this will be disaster relief industries, but eventually it can really be expanded to military operations. If you have a robust enough drone, maybe something on Mars or another planet, really anything where you need a drone of some sort to collect data and return that data securely, even if some nodes were lost in the process. So that encompasses disaster relief, any type of exploration, like I said, military, space, the space industry, but only in some aspects. And then as for prior art on this, like I mentioned earlier, found a few scholarly articles on similar situations, such as this patent for blockchain-based solution for internet drone security and privacy. So this is only using blockchains for internet security and privacy for drones, but it didn't go into any further use cases. As for the next one, this is a little closer to what I'm looking at, as it is a multi-drone SLAM, which is the mapping algorithm simultaneous location and mapping using a distributed ledger, which is pretty much, it's similar to what I'm looking at, but instead of just this, I'm hyper-focusing on mapping in disaster relief areas and ensuring that a human operator can still be a part of this, and this is just completely autonomous. Next, we have Pix 4D Mapper. This is just what's in the industry now. So you have this drone mapping software that is actually used quite a bit in disaster relief in various industries. And then Drone Deploy, which is again similar to Pix 4D Master in that it's currently in use, but doesn't actually include any blockchain or backups, robustness, anything like that. It's mainly one drone and they do the mapping, or it's just the software and you put it on your own drones. AstroSwarm has the potential to be a very versatile project, allowing for precise, accurate, and robust mapping capabilities that aren't at the mercy of their environment. Due to the data being all shared on a blockchain and all sent back to a central human-run node, you have more of a likelihood of getting back the data you need and saving those who are in need. Thank you very much. My name is Damon Rocha, and this is my project.